Hello viewers, welcome to the video lecture titled Introduction to Integrated Circuits. I am Dr. Suman Pattnaik. In this lecture we will study the definition of integrated circuits, the various advantages of integrated circuits over discrete circuits, and also we will study what makes the integrated circuits so small in size, the disadvantages also we will study, and the various classification of integrated circuits will also be covered in this lecture. Lastly, we will study about the common applications of integrated circuits. So let's start with first the definition of integrated circuits. So let's start with the integrated circuit. The concept of integrated circuit is that when a number of electronic components are fabricated to form a particular circuit, and these are fabricated on a single chip permanently, and that chip is nothing but a substrate of semiconductor, which is usually of silicon. This type of circuit is called as an integrated circuit because this circuit is integrated simultaneously on a single chip, and only the connections are provided for the user. The circuit is not visible to the user. Now, the components which are fabricated inside the chip, that are very small in size, of the microscopic in size. That's why we are able to integrate large number of electronic components in a small area of the chip. So the components of included may be active as well as passive components, and these the ICs originated with the invention of the transistors only. So as we can see inside the chip, these are the connections which are provided from this circuit made on this, and these connections are provided to the user in the form of these pins. So in case you want to provide the input or the output, you have to apply the signal at these pins. Now the classification of circuits. What do you mean by circuit? First, circuit is the interconnection of various electronic components, and electric current flows through it, and these are depending upon the applications and the type of the fabrication. These are classified into discrete circuits and integrated circuits. What are discrete circuits? Discrete circuit means the user is able to view the connection of the circuits, even the components are visible to the user, and it is easy to dismantle or remove any component from the circuit. As you can see, this is a discrete circuit. So the these diode, transistors, or these are visible to you. These are the capacitor, transistor, diodes. This is also a transistor. These a circuit is made by connecting through these electronic wires. You are able to view the circuit, and also you can change any faulty component through it. But in case of integrated circuit, this is not the case. The circuit is integrated inside, and it is not at all visible to the user. As you can see, this is an integrated circuit. This is a chip. This is a one chip, and the circuit is formed on this is a PCB, and these are the other components which are fabricated. So the circuit inside this chip is not visible to us. So this is an example of integrated circuit. So now integrated circuit is further divided into three categories: analog circuit, digital circuit, and mixed circuit. Now what is analog integrated circuit? Analog integrated circuit means when the circuit takes the analog signal as the input, and after processing at the output, analog signals are available. And this is further divided into two categories: linear and radio frequency. Linear analog integrated circuit means when the output is linearly dependent upon the input, and these are called as linear integrated circuits, such as op amps, voltage regulators, comparators, timers, etc. are well known examples of linear integrated circuits. The radio frequency integrated circuits, or it is also written as RFIC, these are usually operated in at a particular frequency and are generally used in the mobile phones. In mobile phones, they are operating in the frequency range from 3 kilohertz to 2.4 gigahertz. So now coming to the digital integrated circuit, now you can very well know the digital ICs takes digital as the input, digital signal as the input and digital at the output. And the examples are various logic gates, multiplexer, demultiplexers. All these are the examples of microcontrollers. All these are the digital ICs, flip flops, counters. All these comes under the digital ICs which operate on the binary data such as 0 and 1. And in digital circuit, 0 normally represents 0 volt and 1 is represented as 5 volt. So other logic may also be there, but generally this is the followed logic. And in case of mixed integrated circuits, we are now using the digital as well as analog signals. And the example is an A to D converter, means analog to digital converter, and digital to analog converter, microcontroller. All these are included in the mixed integrated circuits. Now the disadvantages of discrete circuits. As you have seen discrete circuit, which is very well. So first is the time consumption in assembling and wiring of all the individual discrete component is very high as compared to the integrated circuit. And the circuit size is also large because the size of the component is large, so the circuit sizes and the space occupied by the circuit is also very large. And the replacement of the faulty component is very complicated. It may lead to even the damage of the PCB. And these are less reliable when we are talking about the temperature and the vibration variations is there. So next is the what are the advantages of integrated circuits? They consume less power consumption, and the size is very less because of the component size is microscopic, is very small. That's why the size of the integrated circuit is very reduced. Power is reduced, size is reduced, and they are available in wide range of packages, flat package, DIP package, like this. And the cost is very small because they are produced in the bulk. They are less costly, and these are reliable and can operate on high frequency and high speed. Because of the absence of parasitic capacitance, they can operate with high speed. But there are some disadvantages also, but the advantages are more as compared to the disadvantages. So in integrated circuits, we cannot modify the circuit, cannot be modified after fabrication, because the circuit we have fabricated permanently on the silicon substrate, and the whole IC has to be replaced in case of any damage, any fault is there. And for if we want a high in the circuit a high capacitance of very high value, that is more than 30 picofarad, we have to use an external discrete capacitor to it. And similarly, we cannot produce high power ICs more than 10 watt in case of integrated ICs. And also the inductors and transformers that cannot be integrated inside the ICs. So we have to externally connect these inductors and transformers if that is the need of the circuit. And these also get easily damaged due to the overcurrent flowing through them. As also the size of the IC is very small, and IC is unable to dissipate heat in required rate when current in it is increased. So IC get damaged due to overflow of current. Now the classification of ICs on the basis of chip size. As we know, we are able to fabricate large number of components in the small area. So as the technology is goes on increasing or is improving day by day, so more and more number of transistors are incorporated in a single chip. So depending on the number of transistors incorporated, the IC can be classified into 6 categories as shown This first one is the small scale integration. This is SSI. We write it as small scale integration. And next one is the medium scale integration, MSI. And this is large scale integration. This is very large scale integration. This is ultra large scale integration. And last one is the GSI, that is giga scale integration. So as we are moving from SSI to GSI, the number of transistors or the number of components are increasing inside a chip area, and the size goes on decreasing, but the number of component inside is increasing. So let's study about all these 6 categories in detail. So as you can see, in case of SSI, it came in the year 1964 with number of transistors ranging from 1 to 10 and the number of logic gates less than 10, and the application of SSI includes the logic gates. MSI came in the year 1968 with the number of transistors ranging from 10 to 500. So what is means the now up to 500 transistors can be fabricated on a single chip, and the number of logic gate also increased from 10 to 100, and the application includes flip-flops, adders, counters, mux, demers, etc. And then came the LSI in 1971, and the number of transistors from 500 to 20,000 with the logic gates from 100 to 10,000, and the applications include small memory chips and the programmable logic devices. VLSI, very large scale integration, came in 1980 with 20,000 to 10 lakh number of transistors and 10,000 to 1 lakh number of logic gates, and the applications include large memory chips and complex programmable logic devices. Then came ULSI, ultra large scale integration, and it came in 1984. And the number of transistors include above 10 lakhs. The number of logic gates from 1 lakh to 10 lakh, and the application include 8-bit and 16-bit microprocessor. GSI came in approximately around 2001, and the number of transistors above 10,000 lakhs. The number of logic gate is more than 10 lakhs, and the application include Pentium 4 processor. So as you can see, now the number of transistors are increasing. The number of logic gates that can be included in a single chip has also increased. As we can see from these applications also, the speed of all these has increased. The memory size is also increasing. So with these are the idea of all these categories of ICs. Next categorization is based on the fabrication. How these are fabricated, and these are broadly classified into 3: monolithic, CMOS, and hybrid. So monolithic, as we know, mono means single. So when all the ICs, all the components, active and passive, are formed simultaneously by a diffusion process. This is done with a diffusion process, and it is done on a single substrate. So then the metallization process is used in the interconnection of these components to form the desired circuit. So the electrical isolation between the components in the monolithic ICs can be achieved by there are many number of techniques to achieve the electrical isolation between the components which are placed on the substrate. So when a whole circuit is placed or formed on a single chip, that makes the low cost and also makes the mass production of those ICs possible. The monolithic ICs exhibit good thermal stability, and because all the components are integrated on the same chip, and these are very close to each other. In case of CMOS ICs, the technology used is the complementary CMOS transistors are being used, and as we know, these consume less power and they are very high speed. Next is the hybrid ICs. So in hybrid ICs, the passive components such as resistors and capacitors, these are interconnections. Their interconnections are formed on by using the monolithic technique, but the other active components such as transistors and diodes, then afterwards along with monolithic passive component fabrication, and then they are connected to form a complete circuit. So unlike monolithic, these are not the whole circuit is not fabricated simultaneously. Passive are formed separately, and then these are fabricated along with the active components. So hybrid ICs are further classified as thick film and thin film. Thick film and thin film hybrid ICs. Depending upon the method that is used to form the resistor, capacitors and related interconnections on the substrate. So when a suitable material is evaporated on a substrate in forming resistors, capacitors and interconnections, a thin film hybrid IC is obtained. On the other hand, a thick film hybrid IC, in the thick film hybrid IC, the resistors, capacitors and the interconnections are etched on the substrate by silk screening. These in case of thick screening, the components are etched by silk screening. This is the case of thick film. And in thin film, as I have already told you, the suitable material is evaporated on the substrate to form the resistors, capacitors and the interconnections between them. Next is the classification on the basis of the packages. So on the basis of packages, these are divided into 4 categories. DIP is dual inline package, SMT is surface mount technology, and then quad flat and ball grid arrays. So DIP is, as you can see, this is DIP. DIP means dual inline package. So this is dual inline package. So as you can see, these are the sockets which are used in the circuit to protect it from the frequent change of the ICs. Any damage to the, when a socket is soldered on the PCB, you can place any IC on this socket and the connection is made with the PCB. So this helps in the frequent debugging and soldering of the IC. So in the breadboard, the DIP IC can be placed like this. And the other is the SMT. SMT is surface mounting technology. So as in case of DIP, we are provided with the pins that are put through the hole in the PCB. But here you can see the pins are soldered inside the, means on the PCB. They are not going through the hole to the other side. So this is a surface mounting this is called a surface mounting device, SMD, and these the technology that is called as SMT, surface mounting technology. Next is the quad flat. Quad flat type of packages like this. Quad, this is a square type of IC with the pins or the interconnections are provided on at all these sides. As you can see, at all the 4 sides the connections are provided in the quad flat package. And the other are the ball grid arrays. In ball grid arrays, as you can see, these balls are provided in place of this pins. The connections are now made like this. So these are the classification of the ICs on the basis of packages. Next comes the widely used applications of these ICs. Now we are very well understood of the ICs. What are ICs? Which are the circuit is not visible to the viewer. Only the pins are provided for making the connections for input and taking out the signal as output, and the circuit is not at all visible. If any fault occurs to the IC, the whole IC has to be replaced, and the full circuit of either it is a half adder, full adder, the full circuit is formed inside a small chip, right? And the wide applications are logic gates, operational amplifiers, counters, registers, memory, timers, power supplies, calculators, microprocessors, microcontrollers, temperature sensors, and many more. So these are the various packages, as you can see: DIP, flat, circular. All these packages are available for the ICs. So the user can use according to its own requirement. Next is, this is a particular IC I am showing you. In every IC you will see a particular notch is there. This type of notch is there, right? So when you keep this notch on the left side of when you place this IC in such a way that this notch comes to your left side, then the pin below this notch is a dot is there, or if no dot is there, then also by default the pin below this notch is the first pin, and a notch is placed means this is the first pin, and the other pins are read like this. This is a notch and this is the first pin, and then moving from this to this side 1 to 8, and then from this side to this side reading from 9 to 16. So in this picture, this is a 16 pin IC. As you can see, this is a 16 pin IC. So all the ICs pins are read like this. So there are various manufacturers for ICs: Fairchild, National Semiconductor, Motorola, RCA, Texas. All these companies are making the ICs. And when we are going to purchase any IC, we have to order it by a number, and when it is written as LM741, this means that it is a product or it is an IC that is manufactured by the National Semiconductor. LM, LHF, LF, this is from the National Semiconductor, and 741 is an OPAM. So the number tells us the device or the circuit we are to use, and this is the after the number there is a package type is also mentioned. So all these information or the specification of this IC can be known from the data sheets. So data sheets are also provided by the manufacturer to know what is the maximum operating voltage of that ICs, what is the temperature limit, what are the various pin configurations, what is the circuit, at which pin which voltage is provided, where is the input, where is the output. So all these information can be gathered from the data sheet. So these are the references. Thank you so much. So I have covered only the basic concept of the integrated circuits. So many more is going to come in my further videos. Thank you. Thank you viewers for watching this video lecture. So please give me the feedback by giving your comments in the comment box how you like this video, and also if you have any doubt, please do write in the comment box. I'll try my best to answer to all the doubts which you have. Thank you.